Okay, welcome everyone. Thanks a lot for being on time, and I hope you come for the right session. I think I advanced a little bit. Yeah, this session is all about unlocking this new feature on Docker Desktop for now Containerd image store, and we're going to see what that means and what kind of feature these new features are going to enable on Docker Desktop. And my name is Jorge Arteiro. I'm a cloud developer advocate for Microsoft, and I also 3 months ago became Docker Captain. The shirt here, the nice jacket they sent to us. They're very kind. Invite us to come here. Thanks to Docker for the invite. And I have Paul here from my team as well. Thanks, Paul, for attending as well. And we have the main Containerd maintainer, Akihiro Asuda. Thanks for being here. Then at the end, if you have any question that I don't know, I'm pretty sure that Akihiro is a legend. And thank you so much, because without your support on Containerd, not Docker, anything, nothing is going to work. We all depend on Containerd. And yeah, and what I say, let's get started and let's go like hands-on and show what's that on Docker Desktop. Because pretty much, enable on your IDE on Docker Desktop. I call that Docker Desktop IDE now because it can do so many things there, or like a GUI, and if you start in containers in 2014, 15, beginning of the Docker, and it was pretty hard to do anything. Like before Docker everybody knew that wasn't that easy. And just like running commands on the command line, it is something that we tried for years to get adoption. And Docker's growing, and Kubernetes. But I think we start going back now to have kind of IDE. I work for Microsoft, and I remember I come from the Visual Studio time where, people move from Linux command line and start getting, I want to just something more easier to get started. I think that's what Docker is trying to do with Docker Desktop. And this talk is going to enable 3 main things. In my opinion, I got this slide from Akihiro that showed that, why this slide's not holding that? That diagram showed the performance of maybe just this, that's fine. Show the performance of loading the image from the registry. That's one of the main benefits of Containerd. That's now you're not going to wait for all the files from that image to be downloaded to start, with the container. The container can start before even loading the files. They're just going to get the files on demand. That's called lazy loading. And that wasn't possible before. And the biggest percentage of the startup time of a container is exactly the downloading of the image. And once we fix that problem, that's why there's a lot of work being done on that, on Containerd project. And we're going to see that. But don't worry, we're going to explain where Containerd is sitting next to Docker Desktop and Docker itself very soon. But the first thing is the lazy loading. The lazy loading there is, you can see the difference in performance on this graph. The second one is the WebAssembly that everyone's talking about. For us to be able to run WebAssembly on Docker, the Docker daemon, the Docker D, the Docker engine, or Moby, they're all the same thing. They never implemented on Docker engine or Moby, like Docker Community Edition, all the same thing. All these names are the same, means the same thing. Docker engine, Moby, Docker Community Edition, they all means pretty much exactly the same thing. And they never implemented the image management of Containerd. Docker created Containerd and donated to CNCF, I think back in 2017, but was pretty much for running the containers. But they never implemented the image management side on Docker Engine, on Community Edition. That means that now that Containerd is at CNCF is growing, with help with Arteiro and others, and they are moving very fast on Containerd, improving new features, and we need to catch up. And one of the features is like multi-platform build, and also now the WebAssembly is going to depend on OCI, and we need Containerd image to be on Docker daemon, to be working on, to be available on Docker desktop. And Docker has worked on that. That's still experimental. It's not finished, but those are the 3 reasons that we are here today on this session. And then Containerd, I have this slide for a long, long time. I was explaining, Containerd like that. Docker daemon calls this high-level library. I call it like a library because it is kind of a library, and where your application, in this case, the Docker engine, the Docker-D, is consuming this high-level library called Containerd to run your containers. And run C is the runtime they use to run the container, and then all the magic happens on C groups and namespace where they create your container there, all on top of the Linux kernel. That's the basic of containers. But they never implemented, they only calling Containerd there to run the container. All the downloading of the image, everything, unpacking the image was done by Moby in a completely different implementation from Containerd. Because they donated to CNCF back in 2017, but they never changed the code on the management side. Then in parallel, Containerd was creating those, the same code, and using OCI spec, and now they're trying to catch up and leverage all the code that was done by Containerd itself. And that's the first high-level implementation of Containerd, like the diagram of the architecture, is that maybe this one will be very complex for today, but you talk with Containerd by gRPC, and you have these main components of Containerd. One of them that we're going to talk today is like image. All the containers, tasks, all when you run the container, but the image is the main component. Without the image, you don't do anything else. The image, the snapshots, and Containerd use a lot of what they call plugins, and most of these snapshots are developed as a kind of extension, as a plugin. And the latest load one that we're going to talk about, star GZ, is a snapshot plugin as well. And then you think about, I see these as like 2 main things: the runtime and the image management. That's what Containerd. There's a lot of details there you're going to see on the next slide. But the latest version is, I think, is at 176. It's correct, Arteiro? 176, latest version. And if you see his name is there, Arteiro is on the list. Phil, that from AWS, used to be from IBM. There's a lot of people from companies that maintain Containerd since the beginning. And it's a good way for you to find out what's coming on Containerd, watching the release details there, all the update notes there. It's very important for you to follow. There's a lot of management Kubernetes using version 1.6, but they already have version 1.7. Without Containerd, we don't have Kubernetes, we don't have any Azure Kubernetes service, any managed Kubernetes. They all depend on Containerd. I don't know if you remember, but a year or so, 2 years ago, they announced that Docker wasn't going to be supported anymore as a daemon for Kubernetes, and now only containerd is supported. The latest version of Kubernetes only containerd. And why? Because all this evolution that was done by containerd, and even Linux and Windows containers, they all work with containerd. Like I work for Microsoft, Azure Kubernetes Service, we all using containerd as the runtime framework or library or how you want to call containerd. And if you go really in detail, I don't know how to explain the whole thing. Arteiro maybe knows, but that's exactly how I think one important thing of this diagram is how they run your container. Imagine like a cluster, like a Kubernetes cluster where you have multiple nodes, and you have containerd running on each one of those nodes, because that's the runtime that's going to run your pods, your containers. And there's a new version 1.7 of containerd now. How are you going to upgrade your cluster without stopping your application? Then all those shims for runtimes are very important because they are managing, the shims are managing the life cycle of the container. Then we can update the containerd on the host without stopping the containers. That's something that I got a long time ago that I was trying to explain as the most important thing to explain from this thing is that you can upgrade containerd in a cluster without stopping your containers. Correct, Arteiro? You can update the containerd in a host without stopping your containers that are running. And that's very important knowledge there. But it's all based on those plugins, on the shims, because when you need that life cycle being dependent of the containerd itself. And how that works. The first thing is the client. Everyone that want to talk with, work with containers like Docker engine or Kubernetes itself, they have to talk with using gRPC connection, using this client library there. On Kubernetes, a little bit different. You're going to see it there, but it's not complicated. And one way for you to play with containerd by yourself, if you are a developer, is just getting this library. And the preference is Golang. Why? Because that's the only one available. The SDK, pretty much the library for you to use to call this client, to call the containerd using gRPC is in Go. They are even looking for someone to do for other language, but nobody ever did it. Everyone said, okay, let's now use Go for everything. And that's one of the main reasons people use Go for Kubernetes, because that's the easy way to talk with, to implement those things that you want to talk with containerd. Because that's the only one available, the only library available is in Go. And then you can see the kind of service proxies and that you have there, like container tasks and OCI specs now that become very popular with WebAssembly. And you have to keep in mind that the container hashes where the Docker images is stored. We are now storing more than just Docker image. We're storing anything. OCI artifacts could be just a repository where you can save things. And then Docker hash has become more than used to be a few years ago. You have to keep this in mind. And OCI become very important. And if you go for the APIs, like I said, there are options. That, I think, diagram from the version 1.7, and now we have sandbox management as well. Sandbox will be, kata containers or things that you need complete isolation, like pod sandboxing or container sandboxing, where you need to isolate on the hardware as well, because container is all about kernel virtualization. We isolating using kernel, like operating system kernel features. But with these, we're now bringing also isolation on the hardware. And that's something that Microsoft did long time ago with Windows containers called Hyper-V containers, where you could also have I think Hyper-V Container was the first one, was 2016 when they released, was the first one that could have isolation. It's like a light VM around your container. And now we bring that to Containerd. And there is another thing that's not there that's called, remember the WebAssembly I was talking about? The WebAssembly now you have a runtime where you can, I think there's runtimes coming here. Yeah, the schemes for the runtimes. You see the Kata containers run C on the ACI runtimes. gvisor that also like Kata containers, and the Han HJCS for Windows containers. And you also have for WebAssembly called Run WASM, WebAssembly interface. And that's what's going to allow we run WebAssembly on Docker next to containers and the same way that we are used to. And that Run WASM project was done by Microsoft. Microsoft has like a company that was acquired called Days Labs that developed, is a research group at Microsoft that we developed these exactly to run WebAssembly and on Azure Kubernetes Service. And then now Run WASM is part of Containerd. Docker worked with other companies, and they now brought that together with Microsoft to Containerd with help with the Containerd maintainers as well. And yeah, going back, exactly that's how that works. The container store, there's a lot about the image and the snapshots. The way that the life cycle of an image is like when you do a Docker run, they download the image, and the snapshot is going to unpack the image on the root file system for the container. It's kind of, you have the story of the image, and each container that's going to run, that's going to use that image, there is a snapshot that's going to unpack that. But because we need better performance, we're creating now more snapshots with different approaches. And one of them is that we're going to talk about lazy loading, is the StarGZ snapshot that's be used by Docker Desktop now as default when you enable the new Containerd image store. We're going to see very soon that as well. And those are the schemes and how that works on Kubernetes. Kubernetes also called that, and that's the way that in Kubernetes on each node of the cluster, there is one thing called kubelet, and also Containerd running on the host. Imagine like a cluster with 5 nodes, and you have kubelet, Kubernetes kubelet, and Containerd running, and that CRI plugin is the plugin that is only used by Kubernetes. Okay, because Kubernetes is not, they don't create containers, they create pods. It's a little bit different, the way that we run. Kubernetes doesn't run containers like Docker, they run pods. And that this plugin used to be outside Containerd, and now they move this plugin to be inside Containerd itself, because everyone's using Kubernetes. So it's something that doesn't have to be outside. And they move this plugin inside the Containerd. And then when you do like kubectl deploy, they're going to call, the scheduler is going to call the kubelet. If there is space on that node of the cluster, they're going to deploy your container calling Containerd. Containerd is going to use all those runtimes. Normally Linux is run C, but WebAssembly will be run WASM. And that's the main reason that you have to install those runtimes when you want to work with WebAssembly. And if you want to go more in details, that's how you break. When the kubelet call, they have the image service and the runtime service. And then they're using the Containerd client. Remember the API there, the Containerd client that's in Golang. That containerd client, that's exactly what they call containerd core, that using function calls and pay attention one detail that's very important on this containerd shim. That's complete isolated from containerd. It means that life cycle of this pod, like a pod is more than a container because they create these like pods container. That's why we call pod. And that's the way that Kubernetes manage the life cycle of like one application, one pod with these pods containers. And this guy here, that shim, is just managing the life cycle of your pod or container, how you want to call that. And for each one, have a shim there. It's like managing the whole thing. That means that if your pod stops, they know, and they can maybe restart, or they can just stop the whole process there. But you can keep updating the whole containerd without stopping your pods at the bottom here. And they have all integration with networking, CNI plugins, and now we have some kind of resource manager. They can talk with the hosts. It's very in details, but that's how we all run our application. You have to understand that because that's how your application runs. When you go for your managed Kubernetes service, or if you have Kubernetes on-premise, you have to pay attention which version of containerd they're using. If you go on Azure Kubernetes Service, release page, for example, for Microsoft, there is a version of containerd that we are using. And every time that we patch the version, we use the next version, you're going to see that. Then you're going to see, okay, Microsoft is using version 164, 163, and you can go on the release page and see what features are available there. Because maybe you're asking something for us that we don't even have deployed yet. It's a version that we don't always deploy the latest containerd version, depends of the testings and how mature is that version as well. And how we try that without Docker Desktop? I'll show how easy is that with Docker Desktop to enable what I just said here. I have Docker Desktop running. And to enable containerd on Docker Desktop, you have to go in Settings, Features in Development. There's a beta feature here, and you just have to enable containerd for pulling and storing image. And also, if you want to do WebAssembly, enable WebAssembly. As you can see, there is a dependence between WebAssembly and containerd storage. And I also recommend you turning these new blade called builds. And those experimental features called SBOM indexing is very important if you're going to use with OCI artifacts. It's pretty much index everything that's inside your Docker image. Then they know every single file or every single artifact that's inside the image. They kind of using the index. And for Docker Scout, who watched the Docker Scout, the security at the keynote, we're going to need that. We're going to need these to simplify because we're caching these. Every time that you do a Docker build, if you click on that button there, we're going to index the image that's installed. Then when you go Docker Scout, we have this already indexed. It'll be faster, understand? Then I recommend you to enable that because at some stage you'll be default if you want to do security on Docker Desktop. And we're probably going to do, everyone's going to do. And yeah, once you enable that, there's one catch there. If you have Docker images already, once you click there, those Docker images, they're not going to be deleted, but you're not going to be able to access because a complete new repository for your image. Then all the images that we're using, if you have Docker Desktop already, once you enable, you're not going to be able to see that anymore unless that you unselect that. You're not going to lose anything, don't worry. But it's a different repository from how it was before because now we're using containerd for that. And once you enable WebAssembly, what happens is they're going to download and install the WebAssembly runtimes for you. There are multiple. There are WASM Edge, WASM Time. There is the one from Microsoft called Slide. There is Ping. And they're going to download those and put that for you. That simplifies a lot of things. And if you don't use Docker Desktop, and now it will be my funny demo, like I talked with Akihiro yesterday, and I said, how about I show that, some people asking, I don't need Docker Desktop, I can just, install Docker Moby on Linux and do myself, do the whole thing. And I say, yeah, you can use netctl. There's a command line tool that was done by him, by Akihiro. That's kind of a Docker CLI, but for containerd. It's called netctl. And netctl is part of containerd now, was donated by him to containerd, and it's part of containerd. It's a CLI for containerd. There is a simple one that's more for development, that's called CTR, and there is the one that he developed that's pretty much a clone of Docker CLI just for containerd. Why he did that? Because when he did it was before Docker started working on that. But now that Moby and Docker Engine are going to do the same thing, Docker CLI will be available using containerd. It will be fine. You can use both. But the point is, if you don't have Docker Desktop, how is that easy for you to enable all those things? And I talked to him and I tried to do myself last night. And I did it. I don't have a Mac. As you can see, I have a Windows machine here. And on Windows, we have something called Windows Subsystem for Linux. Who knows about that? Windows Subsystem for Linux. Windows Subsystem for Linux is pretty much very lightweight, and we're pretty much using the same container technology on Windows that we isolate our environment. And it's pretty much a full Linux. You have a Linux kernel. Who knew that now we have Linux kernel running on Windows? Yes, we have a Linux kernel running inside Windows, even Windows 11 like this one. And that's how it works. And what I did was, just to show the complexity, then even if you yourself are able to do it, think about my whole development team are going to be able to be not just creating the environment, but keep updating this environment every time there's something changed. There's a new snapshot, there's a new version of that. Understand? There is a complexity on that. And that's the amount of complexity I'm going to show you now. Oh, sorry, that's not my, sorry. Those are all the steps that we need to do the same thing Docker Desktop is doing. You're just using the open source Moby project or Docker Engine Community Edition. It's the same thing. What I did was I created a WSL distribution. Then from that distribution, I have to do a configuration on Windows Subsystem for Linux to use systemd, because they now works with systemd as well. There's a full Linux. Then that's what I did. I enabled systemd on Windows Subsystem for Linux. Then I terminated that just to restart with systemd on Linux. And the funny thing is, it's easier to do that on Windows than on Mac, because on Windows, on Mac I probably have to do now what another project that Akihiro did to simulate like Windows Subsystem for Linux on Mac. You do kind of similar idea. And, but on Windows, we can create multiple Linux distribution without having to have like a full VM. And they're all complete, independent, sharing just some things. And what I did, that's exactly, I installed Docker after that. Command line, all command line, I installed Docker, and then I just set, groups for Docker, and I installed wget because they need, on the get Docker, they need wget. And I think all they need for something else here. And then for you to be able to, after install Docker, for you to be able to work with the snapshotter and the lazy loading, you have to enable containerd snapshotter. So this code here where you have the snapshotter through, the only way you have to restart the Docker daemon, have to set etcd Docker daemon, a JSON file, and you have to, I just enable experimental, the store driver /gz, and containerd snapshotted through. And then I had to restart my systemd, my systemctl. I restart the dockerd, and then it doesn't stop there. You still have to do the configuration for the /gz as well, and that's another configuration that I have to do on containerd itself. Make sure that Fuse is used, because there is a library that you're using here, it's like for the files. And then you keep going. Then after that, we don't have the /gz snapshotter. It's a plugin. Remember, that's a separate binary that you have to download. Then you have to download that. You have to unpack on the right folder. Then you have to restart enable the snapshot itself, and restart containerd and restart Docker. And now we have that. And after that, I was able to just get in there and create an image and just even run WebAssembly. I was possible. I even run WebAssembly as well. And how you know that everything works? How did I know that? How do you know that really works? And that's my environment. That's my Debian. Then I can see here Docker PS. I probably spell it. Or I have probably here. That's the one. It's not running anymore, but I can run again. I probably can. That's it. For you to run like a WebAssembly and you know that it's working, you have to run this command. I can just. You have to set the runtime. In this case, I'm going to use WASM edge. And you have to set the platform to WASM WebAssembly, WASM. But when you set the platform for WASM, they're expecting for you to have the WASM runtime there. If you don't have the WASM runtime, that's going to work. But because that's part of containerd now, then you have this already there. But you don't have the snapshot for the, you don't have the WASM edge itself. You have to download that. And also remember that I had to download the snapshot one. But when this runs, hello world was an average. That's like just a hello world. Means that, how do I know that if I do again Docker PS, I can do a Docker inspect. I think I have this Docker inspect here. And you have to scroll and you're going to see that. What is that? WASM and stage. That's how do you know that the platform is running as WebAssembly and using the snapshot, the lazy load one. Now we prove that we're using lazy loading, we prove that using WASM. And that was without Docker Desktop, but I had to do all that installation there. And it's not very stable. I had a couple of crashes there as well. I don't know what I missed, but work. But took me, took me 2 or 3 hours myself to do it. I mean, and I had to figure out a lot of things. He helped me as well. He gave me some tips yesterday, and I managed to do it. But are we expecting this from the development team? Probably not. Then on this other Windows subsystem for Linux here, I have this connected with my Docker Desktop. This one is a Docker Desktop one. I haven't to do anything. I just installed Docker Desktop, enabled that feature, and that's it. I can run the same thing. I can run the same thing and everything works. And you have the same inspection there. And I think that's the main difference. And I did that just to prove that even if you can, I don't think there is point for you to use. And now Docker Desktop is available on Linux as well. It can have these things, all these things that I was showing here, on Docker Desktop on Linux, Mac, or Windows. And on Windows, you have even Windows containers working on Docker Desktop. And there are so many things embedded on Desktop today, and it's growing very fast. Another thing that I just did like a whole track presentation was about the new extensions. I don't know if you see that. You have to enable extensions on Docker Desktop. And then all those extensions now are available, like see my disk usage, how bad it is. How many gig you think it is? 62 gigabytes of image I have on my disk. I probably can clean up, but those extensions are something that means that all those new features means that probably there's not worth anymore for you to try to do what I did on Linux. I proved that you can. And most important for you to understand that what runs on Docker Desktop is the same that's available, okay, as open source, and that's the good thing on Docker. They donated these things, and they keep updating. They keep updating, Moby with the community, and there's a lot of people using this Docker Engine Community Edition in production as well. And there are other like enterprise engines that are being used by. In development, this is more than enough. And once we have these out of experimental, it's not, it's not ready yet. There are some bugs, but the next are probably 6 months or 1 year, probably be very stable. And if you look at the release logs that are all, every new release they do on Moby, on Docker Engine, there are new bug fixes there, just for the image side, not for the runtime, just for the image side. If you enable that experimental, as I did show here. If you don't, there's no problem. Okay? And go back in a second for see if I can have one slide here more. Then that's the whole thing I did it. And look at this, I had to install the Docker engine on Debian. I had to go on documentation, find out about installation on Debian. Then I had to look at the Docker Moby release. I don't know if you can see, but see the containerd storage backend here? All those things are things being fixed on the image store. And there's a lot. If you go on the release notes, you can see it's a lot of improvements and bug fixes on that. Means that, soon enough will be out of experimental for sure. I always look at that because you can see that it's not something that, nobody's looking for. It's like there are a lot of developers trying to improve these every single day. And yeah, that's the whole thing I did. I had to get the image stored Docker engine. I had to install the snapshotter. I had to do all these things to be able to show what it did on desktop and was ready to go there. We have, I think, 5 minutes. I promised to stop for that. I hope that makes sense. We have a microphone there. If anyone want to ask a question, or just let me know, I can repeat the question as well. And also, I would, say thank you so much for Akihiro to be here and for everything that he has done for us. Again, on this Docker D project. Question? Tell me something, Paul.
So I've heard of WebAssembly for running like legacy code on browsers and stuff, but what's the benefit for using that runtime in Docker? Just kind of, I know it's like an open-ended question.
For using WebAssembly. Yeah, it's a good question. Yeah, this talk wasn't really for WebAssembly, but it's a good question, and you're going to have other sessions on WebAssembly. For sure,
Or maybe
we
not
have.
WebAssembly, but
But the main thing is like, why we did at Microsoft, we did run WASM. WebAssembly is not like a container, it's just a binary. Okay, we create a Docker image just saying, compile, get the WebAssembly binary, and just you put inside the image. That's it. And you just run that. But the difference is like you can boot like a WebAssembly application because there's a single binary and there is no kernel or anything like a container in microseconds. But if that's not milliseconds, is not a problem for you, if you need microseconds. But there's a lot of things that you're not going to be able to run today on WebAssembly. Then still today, like a very edge case, it's very good for edge computing where you need that because you don't have the full image, it's just like one binary. Right. That could be kbytes or like 3 or 4 megabytes, the whole WebAssembly running there. Then you spend less memory, boots very quick, and yeah, it'll be very nice for edging. But they're trying to expand. They're trying to do WASM X now. They're trying to bring like threadies and things that are more from like operating system, like a kernel, to WebAssembly as well. There's a big discussion happening if you should do that, if you should not do that. Yeah, but thanks for the question.
Thank you. Thank you.
That makes sense. Hope that makes sense. And I have on the browser, just as a recommendation on the running WebAssembly on Docker, you can see the same thing I was showing there, the commands. And on that documentation, you can see the different runtimes that you can play. And each one of those runtimes, just extending on the WebAssembly question, that they can bring you more functionality. It's kind of, WebAssembly is all about bindings. You can have bindings to talk with other things. Because one of the advantages of WebAssembly is like sandboxing for security. But once you are running inside the box now, how will you talk with the outside world? And that's all the binding thing. And yeah, but that's a very good question. I think one of the main use cases that they work on that is because WebAssembly itself. Okay, but run WASM is this project, is inside containerd, run WASM. And that's the icon I was showing there, very funny one. And those things are not going to disappear. There are some good examples. And a nice one is when you push this to Docker Hub, and if you open like an image, you're going to see this architecture, WASM. But it's the same. You can push this to Docker Hub the same way that you do with a normal image. And you're going to see the WASM there. And the same thing for OCI now on Docker Hub. You can use OCI, that you need containerd for that. And you can do things like, on this one, I don't have it. But let me go on this. On this one, I have like Helm. I have other things. I have like a Helm chart that I push here just to try. It's not like image anymore. It's like artifacts. Artifact or Helm could be anything. A Helm chart. And that's one of the things that we're enabling with containerd as well. And yeah, that's the fun. If you don't know this project, also I recommend you to follow. It's from CNCF, was donated by Microsoft. And that's pretty much when we start work with OCI. We created like a reference implementation for you to push things to work with OCI image. And you can use this CLI or ORAS to push things to the container. That's it. We are on time. Thanks a lot. And any question, take outside. Thanks so much for coming.